Hi, this is Engineer Earnhardt, your professor in numerical methods for ordinary and partial differential equations, or MATH221P. Our suggested textbook will be Numerical Methods for Engineers and Scientists, an introduction with applications using MATLAB, 3rd edition by Amos and Vish. In a rapidly advancing digital technology, numerical computations plays a vital role for logical operations. So, why is it important to study numerical methods in engineering? First, numerical methods are extremely powerful tools in solving engineering problems, many of which are impossible to solve analytically, especially those differential equations that involve nonlinear non, nonlinearities and non-elementary functions. Because most of numerical methods require the use of computers, it would also be an effective way to learn programming. This course begins with introductory topics in numerical methods, including numerical solutions to roots of equations and systems of equations, interpolation, integration, and curve fitting. The main part of the course will focus on the solution of differential equations and partial differential equations. This course will provide you with the skills and knowledge required to perform fundamentals of numerical methods with the aid of Excel, softwares, and MATLAB for solving linear equations, nonlinear equations, differential equations, and partial differential equations. Upon completion of the course, you should be able to apply numerical methods for solving nonlinear equations and systems of linear equations, calculate errors, and recognize the relationship to the accuracy of the numerical techniques used, apply numerical methods for solving ordinary differential equations and partial differential equations, develop structured and modular programs using MATLAB to solve ordinary differential equations and partial differential equations. So for the course outline, okay, so for the first 4 weeks, we will have the following. Week 1, course orientation, and then I'll be giving some notes for linear algebra, and you'll be given a diagnostic exam, which is to be uploaded in the Blackboard and will be available for the whole week. And then for next week, or week 2, we will discuss solution of linear systems, Gauss-Jordan reduction method, the Gaussian elimination, solution by inverse using MATLAB and Excel. Then you will have your practice set 1.2. And then for week 3, we will be discussing LU decomposition method, the iterative methods, Jacobi and the Seidel method, rather Gauss-Seidel. And then you will do your practice set 1.3. And then for the following week, you will have your quiz number 1. For week 5, we will have the solution of nonlinear equations, using bisection method, regular facile method, fixed point iteration, secant method, Newton's Raphson, interpolation method, the divided difference method, the least squares approximation. And then quiz number 2 on week 6. And then for week 7, we will have numerical differentiation and integration, we will take up the following methods: a forward finite, backward finite, centered finite, Richardson's extrapolation, trapezoidal rule, the Simpson's one-third rule, Simpson's 3/8 rule, and then the solution of first order differential equations, the Euler's method, the method of successive approximation, Taylor's theorem, the Ranskata method. And then you will have your practice set number 3. And then week 8, you will have your quiz number 3. Week 9 will be solution of partial differential equation. So we'll be discussing the different types of PDE. And then the solution of Laplace equations using finite difference. And then iterative methods such as the Liebman's method. And then you will have your quiz number 4 on week 10. And then week 11 will be submission, the final submission and presentation of your machine project, of machine problems or your group project. So for the assessment of the course, we will have 20% problem sets. Long quizzes will be 60% of your final grade. MATLAB project will be 20% of your final grade. So this will be considered as your final examination. And then for the group project, you need to create a program, preferably MATLAB, that will solve a numerical problem. The problem should be any engineering applications related to your program. So one program for each topic, ODE and PDE. So each group should have 2 members. So you will be asked to submit the hard copy and soft copy of the project. The grade of your project will be based on the following: 60% technical content, so that includes documentation, program design, user interface, etc. And then presentation will be 40%. Knowledge power, so that includes knowledge, PowerPoint participation, etc. I hope you will have a good online learning experience in this course. Good luck.